Let's talk about the acid-base properties of water. When a species can behave either as a Bronsted acid or base, it is called the amphoteric substance. So it can either act as an acid or a base depending on the conditions. As an example, like water can both accept a H plus or it can uh, donate an H plus. So the water can both act as a Bronsted acid or Bronsted base. So let's look at the ionization of water in ionization of water. When you look at the ionization of water, it can the water can ionize to or it can produce the ions of H plus and OH minus. So we can write, so this is in equilibrium. That means it partially ionized. There is no complete ionization. Therefore, the reaction is in equilibrium. There is a forward reaction and a reverse reaction. So we write the equilibrium constant. For this, the equilibrium. So if we write the equilibrium constant for that, we can get the multiplication of the product concentration in the numerator, and here these are in aqueous mode, and the H2O concentration. H2O is in liquid state, so its concentration is a constant. So we get a modified constant. It equals to the concentration of H plus multiplied by the concentration of the OH minus. So this modified constant is abbreviated as K subscripted W. That is for the equilibrium constant for the ionization of the water. That is the equilibrium constant for the ionization of water. So that the value, this Kw equals to 1.0 times 10 to the negative 14 at 25 degrees of Celsius. When we mention an equilibrium constant, it has to be always followed by the temperature. The temperature when that the equilibrium constant was calculated. So in pure water at 25 degrees of Celsius, the concentration of hydronium ion is exactly equals to the concentration of the hydroxyl ions. So we have equal acidic properties and the basic properties in pure water at 25 degrees of Celsius. The concentration of H3O plus or concentration of OH minus equals to 1.0 times 10 to the negative 7 at 25 degrees of Celsius in pure water. Let's look at how we can categorize whether a solution is neutral, basic or acidic. When the concentration of hydronium ions are exactly equals to the concentration of the hydroxyl ions, the solution is known as neutral. When the concentration of the hydronium ions are greater than the concentration of the hydroxyl ions, the solution is basic. When the concentration of the hydronium ions is less than the concentration of the hydroxyl ions, the solution is basic. That's how we categorize, we call a solution is neutral, acidic, or basic. Now, here is a practice problem. The concentration of hydronium ions in stomach acid is 0.10 molar. Calculate the concentration of hydroxide ions. Hydroxide, that is the concentration of this ions in stomach acid at 25 degrees of Celsius. Right. Now, we are given only the um, concentration of the hydronium ions. And how we can attempt this question? Yes, we use the equilibrium constant for the ionization of water, right? Which is equal to 1.0 times 10 to the negative 14th at 25 degrees of Celsius. Yes, we have the similar temperature. So therefore, we can use this value. Right. So then we reorganize this equation to solve for the concentration of the hydroxyl ions. Then concentration of hydroxyl ions equals to 1.0 times 10 to the negative 14th divided by the concentration of the hydronium ions. Now we are given the concentration of hydronium ions, so we plug that value here and solve for the concentration of the hydroxyl ions. Right. So when I say concentration of the hydroxyl ions are equals to 1.0 times 10 to the negative 13, and concentration of the hydronium ions in this solution equals to zero point 0.1. So if I write it in a uh, scientific notation, that will be like this. So what is the greater value? Yes. So the greater value is the concentration of hydronium ions. So we can categorize the stomach acid as in it is the solution. In stomach is acidic.